Welcome back. In this lesson, we continue to look at input devices, and the focus will be on touchscreens, resistive, capacitive, and infrared types. So let's begin by looking at what touchscreens actually are. Touchscreens are hardware that can be classed as both input and output. They allow simple touch selection from a menu to launch an application, and they allow the user to carry out the same functions as they would with a pointing device, such as a mouse. There are three common types of touchscreen technologies currently being used by phone and tablet manufacturers, and you've got to be aware of those. Similar technologies are used in other touchscreen applications. For example, when you go into a mall, you'll probably see an information point, and you can touch that to select where you want to go. Perhaps you go to the local McDonald's and there's a touchscreen where you can make your order. Perhaps you want to buy a train ticket or you're at the airport and then you can use a touchscreen technology there as well. The three types of touchscreen technologies that we're going to be looking at are capacitive, infrared, and resistive. Resistive is the most common type of touchscreen technology out there. Why? Because it's the most cheapest. Okay, so how do we define a generic touchscreen and what are the pros and cons and the applications of a touchscreen? Well, it's an electronic visual display that incorporates an input device that responds to touch. This allows the user to select options from a screen simply by touching them. Therefore, the typical applications for touchscreens include smartphones and tablet computers. So it's easy to input data in those types of devices, and you can select applications by simply touching them. Of course, ticket and information kiosks, because they also allow a limited set of options which you can easily select by touching them instead of typing huge amounts of information. So the benefits of touchscreens include saving space as both input and output devices are combined, simple and easy to use, work well with icons allowing options to be selected very easily. The drawbacks include the difficult to complete tasks that require precision or accuracy, and they're difficult to use if they're damaged. Of course, there's additional ones, visibility. Different types of touchscreens will have different types of visibility. Some are going to be more fragile than others. We're going to look at that all in a moment. So let's start with capacitive touchscreens. Capacitive touchscreens are composed of a layer of glass, which is called the protective layer, a transparent electrode, which is the conductive layer, and a glass substrate, which is the underlying layer. So it's got three layers. Electric current is sent from the four corners of the screen. When your finger or perhaps a stylus touches the screen, the current changes. This allows the location of the touch to be calculated. The benefits for a capacitive touchscreen are that it has very good visibility in sunlight, it's got a very durable surface due to the glass, and it allows multi-touch. Drawbacks mean that because it has glass, it's more fragile and it can shatter on impact. And because it uses electric current, you need to have a conductive material. So you can't use it while you're wearing gloves or any kind of clothing. You need to physically touch it for it to work. Now, capacitive touchscreens are of two types. Surface capacitive screens, there are sensors placed at the corners of a screen. Small voltages are applied at the corners of the screen, which create an electric field. So when a finger touches the screen's surface, this draws current from each of those corners. That reduces the capacitance. A microcontroller measures the decrease in capacitance and therefore determines the point where the finger touches the screen. The system only works with a bare finger or stylus. So basically you've got four corners, all generating small voltages. The moment you touch it, it then reduces the capacitance, and that can be detected by a microcontroller. Projective capacitive screens, on the other hand, use an XY matrix type grid pattern for the transparent layer. This creates a 3D electrostatic field. So when a finger touches the screen, it disturbs the field, allowing a microcontroller to determine the coordinates of the point of contact. This system works with bare fingers, stylus, thin surgical or cotton gloves even, and it allows multi-touch facility, for example, pinching or sliding to happen as well. With the advent of strong glass technologies like Gorilla Glass, this is now becoming the preferred option of touchscreens in mobile phones and tablets. Next up is infrared touchscreens. These use a pattern of LED-based infrared beams to form an invisible grid on the screen. Sensors detect where the screen has been touched by detecting a break in the infrared beams. The position of the touch is then calculated. So it's kind of like a security system for your phone. Imagine a security system where you want to get to an object in the middle of the room and you've got these infrared beams and you break it and an alarm sounds. It kind of works similarly. The benefits are that this is very inexpensive to manufacture. You can use stylus, fingers, gloved fingers, or pens to operate. Anything works. Drawbacks, it's got very poor visibility in sunlight. It's vulnerable to scratching. It wears throughout time, and it does not allow multi-touch because you can only detect the break once, not in different places. Because think about it, when the first beam breaks, the alarm is triggered. Now on screen you can see an example of how these transmitters work. So pause the video and study it. Hopefully this will give you a visual representation of what we discussed a moment ago. The final type of touchscreen we'll look at is the resistive touchscreen. This is the most common because it's the most cheapest. Resistive touchscreens use multiple layers of material that transmit electric currents. When the top layer of the screen is pushed or touched into the bottom layer, the electrical current changes. This allows the location of the touch to be found. So that's basically what we mean by resistance. So you have to literally force it to touch the other layer to detect where the touch has happened. Now the benefits are that it's very inexpensive to manufacture, and also we can use styluses, fingers, gloved fingers or pen to operate it because you're just pushing something. The drawbacks include the same as the infrared. There is very poor visibility in sunlight, it's vulnerable to scratching, it wears out over time, and it doesn't allow multi-touch. So how does it work? Well, the upper layer is made up of a flexible polyethylene, which is a type of polymer with a resistive coating on one side. The bottom layer is made of glass, also with a resistive coating on one side. So these two layers are separated by air or an inert gas. So when the top polyethylene surface is touched and pressure is exerted on it, two layers make contact. Since both layers are coated with a resistive material, a circuit is completed which results in a flow of electricity. The point of contact is detected where there was a change in voltage. So what happens is current flows from top to the bottom layer, and that's basically where you can pick things up. Now there's an image on screen that kind of illustrates all of that with the various different parts. You don't really need to go into that much level of detail for the exam. All you need to know is two layers, put pressure, makes contact, electric current is generated, and point of contact is detected. A microcontroller converts the voltage to digital data, which it then sends to the microprocessor, which then uses that touch data to decide whatever it needs to do. Okay, that's all about touchscreens for today. You should be able to answer the following questions. You should be able to give two uses of touchscreens. You should be able to explain the operation of a capacitive touchscreen. Similarly, you should be able to explain the operation of a resistive touchscreen and an infrared touchscreen. You should also be able to answer questions like which touchscreen type can be used with gloves and why. That's all for today. If you do have any questions, please do get back to me. Otherwise, I'll see you in the next one.